The lesson outcome for this video is, I can recall the main ideas for Unit 4. So the Unit 4 test is around the corner, and there are two standards for this unit's test. Number one, I can solve and graph inequalities on a number line. And the second, I can solve linear inequalities on a coordinate plane. Now these two standards are related because they are both dealing with inequality situations instead of equations as we were working on in Units 1, 2, and 3. But they are still different in ways. First of all, as it says right here, we are going to be solving and graphing inequalities on a number line. So that's the situation we have on this type of problem, where we have a number line and we're doing our circles and then shading and that type of thing. When we get to the end of a problem, when we solve these kinds, we're going to see something maybe like x is less than 8, but greater than -1. And then we are able to graph that with one variable, x, on a number line. The second standard is talking about linear inequalities, and we're dealing with a coordinate plane. So these are the type where we are graphing on a coordinate plane. We will have an equation like 4x plus 2y is greater than 12, for example. Where we have to graph the line and then shade as well. So lots of shading in our inequalities unit. Remember, there are many solutions to inequalities, not just one solution like in many cases in linear equation solving. Or I should say in all cases of linear equation solving. Okay, so let's try a couple of examples. You'll see a number line example at the top, and then a coordinate plane example on the bottom. Again, these are the difference between the two standards that we've been working on. This first one is a compound inequality. If I put my lines down where both of my inequalities are, I'm going to solve this just like I would with an equation. So I'm going to go ahead and start by adding 6 to this so that those will cancel out and we'll be left with 2x in the middle. If we add 6 there, we need to add 6 over here, and we need to add 6 over here. When we do that, -4 plus 6 is 2. The 6 and the -6 cancel, so we're left with just 2x in the center, and then we have 2 plus 6, which is 8. Now we're going to divide every part by 2. 2 here, 2 here, and 2 here. And then we're going to say 2 over 2 is 1, so we have 1x remaining in the center. We are not going to flip our inequality signs because we divided by a positive. 2 divided by 2 is 1, and 8 divided by 2 is 4. So what this inequality says is that x, which I'll start by talking about in the middle, x is greater than, because it's, again, the mouth is opening towards the larger amount, x is greater than 1 and less than 4. So it's somewhere between 1 and 4. So to graph this on our number line, we can start by putting a 0 in the middle if we want to, and put a 1, 2, 3, 4, 5 this way, -1, -2, etc. You'll notice we actually don't need the negative values in this situation, but it's okay to fill in a number line in kind of whatever way you know works. So we need a circle at 1, and we need a circle at 4. And then we have to decide if they are filled in or not. Remember, these are not filled in because it's simply greater than, not equal to. If it had an equal to sign part right here, then we would shade this in because it could be equal to 1. And this is the case with the 4 as well. It's not equal to. So we're going to leave them both open. X is greater than 1. Well, where greater than 1 is this direction. And then x is less than 4, and less than 4 is this direction. So we know our solution has to be true for both of these, which is in between them. The second example about the coordinate plane is y is less than 2x minus 6. So notice a lot of similar numbers in these two problems, but they're solved differently. So this one is a situation where you have two variables, x and y, which means we are going to be drawing our line that this is similar to if this was an equal sign. So we're going to graph it. Remember, step 1 is determine what form you are in. We are in slope-intercept form, which is y equals mx plus b. So we want to write our slope and we want to write our y-intercept. Our slope is 2, and our y-intercept is -6. We begin with b, so we're going to plot that point on our number line right here at -6. I'm sorry, not number line, on our y-axis. And then we are going to use our slope, which is 2, or 2 over 1. We're going to rise 2 and run 1. So rising 2 and running 1 from that original point at -6 will be right here. Now we decide, is this a solid line or a dashed line? That's our second step is plot some points. We already did that. Plot points. We did. Step 3, is it solid or dashed? Again, the decision for that is found right here. It's a less than sign, not less than or equal to. So this is going to be a dashed line when we graph it. So we come over here and we graph this dotted line, dotted or dashed, through those points, and I'll extend it up here as well. And now our last step, step 4, is we need to test a point. Remember, the best point to test will be your origin, if it's possible. And again, that's as long as the line is not going through that point 0, 0. 0, 0 is right here. If we put 0, 0 in for x and y, and it's true, then we will shade where that point exists. So we'll shade here, which means this whole part will be shaded. If we put 0, 0 in for x and y and it's false, then this point should not be shaded, so we would have to shade over here. So we're going to go ahead and put the 0, 0 in. We're going to put a 0 in for y. We're going to put a 0 in for x. We end up getting 0 is less than, 2 times 0 is 0. 0 minus 6 is -6. Is 0 less than -6? Nope. 0 is not less than -6. It's false, which means that this point is not a solution. If this point is not a solution, then none of the points on this side of that line are solutions, which means our solution is found on the other side of the line. Every single point in this region is a solution to the inequality. Just like every point in this part over, let me show you where I'm pointing. Every point in this region here is a solution to this inequality or compound inequality. Okay, here's one more example of each type. Go ahead and pause the video, try these out, and then check back to see how you did. Okay, so the first one is a compound inequality again, but this time it's using the word or. It doesn't change anything. We're still going to just solve for x in both situations, and then we'll graph it and see how things go. So what you should have done is subtracted 4 from both sides of our inequality sign, and we get -2x, and then +4 and -4 cancel out, is less than -8 minus 4. -8 minus 4 is -12. And now we are going to divide each side by -2. And when we do that, a little siren should go off in your head. Woo, woo, woo. When we divide by a negative, we need to flip the sign. So we have -2 divided by -2, which is 1. So we have x. And did you remember to flip the sign? X is greater than 6, because negative divided by a negative is positive, and 12 divided by 2 is 6. Solving the other inequality, we're going to add 1 to both sides first. We have 3x, we have -1 and +1, those cancel, is less than or equal to 8 plus 1, which is 9. I divided both sides now by 3. No siren this time because we're not dividing by a negative. 3 divided by 3 is 1, so we are left with x is less than or equal to 9 divided by 3, which is 3. Again, this or comes back down here, and this is our solution. X is greater than 6, or x is less than or equal to 3. Now when we go to our number line, we're going to go ahead and put some values on here. I know I have to get to 3 and 6, so maybe 1, 2, 3, 4, 5, 6, 7, 8. We need a circle at 6 and at 3. So I put a circle at 3 and put a circle at 6. Now remember, one of these is filled in. Hopefully you filled in the 3 bubble, because this right here tells us that x is less than or equal to 3. So now our shading. So this is an or situation, so one thing or the other thing has to be true for x. So where is x greater than 6? Well, x is greater than 6 this direction, so 7, 8, 9, etc. And where is x less than or equal to 3? Well, x is less than or equal to 3 in this direction. Okay, so where is it true that x is greater than 6, or where x is less than or equal to 3 means we are going to be able to shade this entire side of 6, and we'll shade this entire side of 3. So any values that are shaded greater than 6 or less than or equal to 3 will be true for the inequality, but anything in the middle, anything in here, will not be true for that compound inequality. And the last one, y minus 3 is greater than 1/2 x minus 7. We're going to go ahead and start with step 1. This is point slope form. Hopefully you determined what form this line is going to be in, or graphed using. So point slope form means we want to find a point and we want to find the slope. The point is found by using this x value of not negative 7 but positive 7, and this y value of not negative 3 but positive 3, and our slope is 1/2. So we're going to plot the point 7, 3, so 7 comma 3 is right here, and then we're going to use our slope 1/2, so up 1, right 2. Up 1 and right 2 will give us this point right here. And now we are going to graph the line, and again we have to determine if it's solid or dotted. This time it is dotted because of the greater than sign, but not equal to. So we're going to go ahead and graph the line dotted. And now we have to test the point. Now we've done actually these other steps, I haven't listed them, but step 2 was plot points, we did that. And step 3 was dashed or dotted, and we decided dashed, right? And so step 4 now is to test the point. I'm going to once again use the point 0, 0, because that is a point that will work to test. It's right there. When I put 0, 0 in, I'm going to have 0 minus 3 is greater than 1/2. Let's see, 0 we put in for x minus 7. All right, so 0 minus 3 is negative 3, is greater than 1/2 times 0 minus 7, which is negative 7. So now we have negative 3 is greater than 1/2 of negative 7. Well, 1/2 of negative 7 is negative 3.5. So this one we have to think about a little bit. Is negative 3 greater than negative 3.5? The answer is yes. It is greater because it is less negative. So this is true, and we are going to shade where the point exists that we tested because it was true for that point. So we're going to go ahead and shade this side of the line, and so all points in the coordinate plane are true for our inequality.